So what 3D scanning gives us the opportunity to do, once it's been stickered up, it's been scanned, is that we're able to output a file that is essentially a millimetre accurate version of the interior of a car. The scanner that we use obviously has an extremely high resolution, so we're able to get the fitment of the cage perfect. All the plates that get welded into the car are perfectly contoured, perfectly notched to the car's floor, and any objects that we need to position within the car are orientated pretty perfectly. The scanning is completed by hand, it's then checked, and the file that's outputted is then pulled into our design software, ready for us to start designing the cage. The design software is great because we're able to manipulate different parts to make sure that the fitment is perfect. And unlike a lot of other cage manufacturers out there, we're able to get skin tight fitment, which is great. So once the scan's been referenced, so making sure that up is up, down is down, left is left and right is right. We then start positioning foot plates into the car. So with this being a half cage and we're designing a track day half cage for this, we need to try and get some large area plates into the section just behind the B-pillar, with this being a 5-door. If it was a 3-door, the B-pillar would be a bit further back, but usually they'll sit just in front of the rear seat bench on the floor. A nice large area gives the plate a good surface area so that it won't punch through the floor if you were to roll over. And we've got some funky contours here, so I've put some reference planes in, which I am just drawing up some foot plates. So obviously the first part of designing the cage is to get a foot plate in there. So we need to get it sort of as far back towards the rear bench as possible, nicely in a corner. This car that we're doing the foot plate for has a nice flat section here, and then it's got a kick down there. So we've put a flat section, a little kick down on there. We're able to check the plate area, make sure it meets what we want it to meet. There's a minimum area that we work to. And from here, we're able to start drawing tubes up off this to start producing the actual cage itself. So when the foot plates are in the car and we're able to start designing things, the first thing we do is design the hoop. Now, on half cages with trim, we like to get them pretty close to all the interior trims. It does make it ever so slightly harder to get the cages into the car to start off with. However, the safety benefits are more than beneficial. The closer you can get the cage to the actual car itself, the more occupancy space you have within the car, and the less chance the car has to crumple before it was to hit you if you were in a crash. So yeah, nice and tight to the car makes it better. So obviously with a half cage, we're only able to go as far as the interior trims because most half cages will be running with the trim in the car. However, when it comes to full bolt-ins and full weld-ins, we're able to get the cage itself skin tight to the body of the car. With a full weld-in, this means that the cage is able to be stitched to the shell itself. This means that the stiffness of the cage and the stiffness of the shell work in parallel. They sort of compound to make both of the parts work together and increases the stiffness massively. When you're buying a roll cage, the layout of the tubes and the design of the cage obviously has a large impact on both the weight of it and the stiffness of it. So starting on our basic range of half cages, which come with a rear diagonal and a harness bar across the rear. These are the lightest cages that we offer, however they aren't the stiffest cages that we offer. This is due to the fact that it's only got a single diagonal in the rear, so you do have one unsupported leg there. Obviously this can lead to a slight bit of compliance in the rear. It's not as impactful in newer cars that have stiffer chassis, so if you're getting something and you just want something for rollover protection and harness mounting, and for as light as possible, then a basic cage might be for you. Most people do, however, go for our standard range of half cages. This comes with a full cross in the rear, so the cage is symmetrical, you've got the same stiffness on the rear. Both legs are supported, so you don't have a floating leg that's able to be compliant in the rear. These all come with harness bars in the rear of the cages, whether it's 2 separate harness bars in the rear cross or a single bar across the lower rear. And then finally, our strongest and stiffest half cage is our hoop crossed version. This comes with a cross in the rear of the cage and a cross in the front of the cage. Now for some models, obviously it's model dependent, the harness bars will be moved from the rear cross to the front cross. The limitations with this are that for taller drivers in smaller cars, you may not be able to put your seat as far back, but you can drop us a message, find out all the details and see whether the right cage for you is what you want. So as well as selecting the specification on the design for the half cage, depending on whether it's going to be a basic, a standard or with a hoop cross, another main part of the selection is the material as well. So T45 is twice as strong and twice as stiff as standard CDS. This means that we're able to use a thinner wall thickness to make the cage. So a CDS cage and a T45 are as strong and as stiff as each other. However, a T45 cage is between 20 and 30% lighter. This makes a major difference on a cage that's got more options. So we would always recommend to select T45 if you're selecting a higher spec cage.